All right, so in the last couple days, we've been approximating area with rectangles, right? But do we like mathematics to be an inexact science? No, we don't. So think with me here.
We try to make it a triangle.
What happens? So here would you guys be quiet? I have pretty big rectangles, right?
I make them smaller.
What if I make them smaller?
Better estimate, yo.
It's a better estimate, yo? I can chill with that. Oh yeah, the old guy just said that, didn't he? Okay, so the more rectangles, right, the better the estimate. Ben? Yeah, me too, Josh. Are we okay to continue?
Yes, sir.
That's a perfect answer. So the more rectangles, the more accurate. So where are we going to take the number of rectangles?
To infinity.
Right. Remember, that's n. So we need n to go to infinity. Okay, so we're going to take the limit as n goes to infinity of what we've been doing. All right. And it's going to give us an exact answer. So the first thing you want to see is we have to express our sums in terms of n somehow, because n is not going to be a number anymore. N is going to be headed towards the infinite. So okay. Those two are equivalent expressions. So when we take the limit, we can actually evaluate it. Unfortunately for us, you'll see a lot of this stuff just drop to 0. Okay. The other two are on page 292. Do you want me to write them down?
Yeah.
Okay. We'll run into j. J squared is, again, you'll have to memorize these. And then there's j cubed. Okay, those are the three we're going to use mostly. They're called power sums. They spend time in the weight room, apparently. Haha, yeah, shut up, Mr. Okay. Let's, the best way I know to do this is to show you. Okay, so we're going to find the area under f of x equals x over 0, 4 by taking the limit as n goes to infinity of the right-handed endpoints. Whoa, calm down there, Debbie. No need to get, never mind. Okay, so Rn. Okay, so that's from yesterday, correct? Okay. We need the change in x. What is that?
Oh,
So 4 minus 0 over n. N is not defined as a number this time.
so we have no in.
We're gonna, and A is what? 0. And then J is just J for now. Okay. I'm a fatty. 205. Oh, that's just wonderful. How much do you weigh?
No, I was just saying.
She's avoiding the topic.
What happened? I didn't hear it.
I just got called a fatty.
I weigh like 160.
You do not weigh that much. Skinny. You just set me off, Debbie. Don't talk again. What? Okay, this right here. What does that work out to? If I plug it in for x, that term just comes out, correct? It's just 4j over n. So what I end up with is 4 over n. Oop, that should be a typo. Okay. Now I'm going to simplify it one more time. Yeah, we're going to pull the 4 over n is just a constant, so we can pull it out. 16 over n squared. And we end up with that.
And now we can do that one power sum. N squared over.
Okay. Are you guys with me, you rookies? Not the old guys.
That looks.
You be quiet. This right here is a power sum, right? So we're going to substitute.
Oh.
Yeah, that's a power sum. So we have 16 over n squared times.
Oh, we're just squared some of the.
Yeah, rookies. Yeah, those are 2s. Okay. So that's the power sum for this. Now distribute. And what do we get?
Yes.
Okay, so that's our final simplified formula.
And then what?
Now we're going to take the limit as n goes to infinity.
Yeah, because then you get 8 plus 8 is.
What's the limit of that?
8.
8.
Oh.
So our area is 8 square units. Perfect, exact, on the money.
It'll never happen again, but.
We're good to go. Okay.
A squared. Let's go.
Units. It's an area, so I put square units.
What are units?
Hey, do you want me to show you a harder one?
Yes. No.
Definitely.
Okay, if you want, you already have the problems I'm asking you to do tonight, so if you want to watch the harder one, have at it. If you want to start working, feel free. I'm going to do another one.
Oh.
Do you want me to do left, right, left-handed? So I'll do a left-handed limit with you. So when you're doing these, I want you to write down the formula every time. It gets it solid in your brain. Okay. The left-handed formula in summation notation. Okay, so what is the change in x?
1 minus 2 over n.
Yeah, so 2 over n. And a is 2. And then the rest of it just comes along for the ride. All right, what's f of 2 plus j times 2 over n? And notice how messy it's going to get.
Oh, wait.
So we have 2. Okay,
Okay, so we have to put it in there, and now we have to, let's simplify it. Foil.
So would that be 8 J over N?
Yep.
Oh, okay.
So, for number 33, do they want us to do that? When we plus 8 squared is equal to 4.
Yo.
You're just using the power sum spin to evaluate that.
How did we get
Now,
Oh, no.
we just
And
use a constant and we use.
Did I make a mistake somewhere? Yep, I did. So 8 plus 3, 11 minus 2 is 9. 16J minus 2J, 14J.
This is like the easy stuff.
How do you account for
If you want to
the
delete, then
a constant in like number 32?
You move it out front. So it's 8 times the sum of J cubed. Okay. Are you guys with me? Okay, we need to split this up.
put it into different things, right?
3 different actually.
Is it X's or the product? It's Pelican. It's Pelican. 40 times. 31.
Whew. Okay, these get messy. You just have to stay organized, nice and neat. So I've split it into 3 different sums, so I can have J's where I need them. All right. Now I'm going to move all the constants out front. So this is 18 over n. This would be 28 over n squared. This would be 16 over n cubed. Starting to fall out.
Wait, so on the,
It's just a lot of algebra. Okay, this here is just 18 over n. This one, what's the formula for j? N squared over 2 plus n over 2. And then we have this one.
Oh wait, but then Jake, you're all that doesn't.
Nope.
Or what?
Why did I rewrite those? It's the same formula. Yep.
Why is it that in the first one there's 18 and he doesn't have to like for
Because
that?
it's a constant one.
Oh.
1 times whatever.
Oh.
Yeah, is, you know, whatever. Sorry, that's going to be, but I goofed that one up. N. It's, so this first term is 18 over n times n. Okay. Now distribute. Starts tomorrow. Thank you. Okay, let's finish. I distributed all those. Yeah, I put it in thirds because that's in thirds. So common denominator. This is 56 over 3 and 42 over 3. So if we take the limit, those cancel out and we get 112 over 3 as our area. Okay. And that one was more tricky because it's actually a curve. The first example I showed you is a straight line. It's just the diagonal x. So it was very nice. You have some more heavy-duty algebra to do this time. Do you have any questions? Okay.